You may have heard about the famous Hollywood movie named Matrix, but the topic we are discussing here has no relation with the above said Hollywood movie. Consider the following arrangement of numbers. Do you see any peculiarity in this arrangement? These numbers are arranged in rows and columns. This is the first row and this is the first column. These numbers are arranged in rows and columns. It is called a matrix. A matrix is a rectangular arrangement of numbers arranged in rows and columns. Each number in it is called element. Thus, 3, 5, 8, and 4 are elements in this matrix. In this matrix, 3 and 5 is in a horizontal line. So this is called the row. And 3 and 8 are arranged in a vertical line. This is called a column. Matrix is always represented in rows and columns. Consider this matrix: 12, 4, 1, 9, 3, 2. Can you say how many rows and columns are in this matrix? It has two rows and three columns. So we can say that it is a 2 by 3 matrix. The first number represent a row and the second number represent column. Always we name a matrix by an uppercase letter. For example, A is equal to 4, 8, 6, 3, 1, 5. The name of this matrix is A and it contains two rows and three columns. So we can write this as a matrix A 2 by 3 matrix. Now let us find out how many elements are in a matrix. In the above given matrix, we can see that it contains 6 elements. You can notice that it is a 2 by 3 matrix. Therefore, the number of elements in a matrix is obtained by multiplying the rows by columns. Now consider another matrix. A is equal to 3, 5, and 6. It has only one row. We can say that it is a row matrix because it has only one row. Then is it possible to have a column matrix? Yes, we can have a column matrix as well because it has only one column. Consider this example. P is equal to 8 and 7. Only one column in this matrix. So this is an example of a column matrix. Let us consider another example. B is equal to 2, 5, 8, 6. In this example, you can see that the number of rows and columns are equal. It has two rows and two columns. This kind of a matrix is called a square matrix. If the number of rows is equal to the columns, then they are all square matrix, regardless of the element in it. For example, consider this matrix. P is equal to 3, 5, 8, 10, 9, 12, 4, 11, 6, 13, 18, 22, 1, 7, 2, 50. In this matrix, it has 4 rows and 4 columns. So this is also a square matrix. Now consider another example here, that is B is equal to 2, 5, 6, 9, 4, 3. Here the number of rows is not equal to the number of columns. It is called a rectangular matrix. Now let us consider another example. A equal to 0, 0, 0, 0. What you can see in this matrix, all its elements are 0. So it is called a zero matrix or null matrix. This is called null matrix. Now let us consider another example. 5, 0, 0, 0, 1, 0, 0, 0, 3. What you observe from this matrix, you can see that all elements except the diagonal elements are 0. This type of matrix are called diagonal matrix. So this is a diagonal matrix. Now let us consider another example. C equal 1, 0, 0, 0, 1, 0, 0, 0, 1. You can see that the diagonal elements are all 1 and other elements are 0. This type of matrix are called unit matrix or identity matrix. This is unit matrix or identity. Now let us learn about some operations on matrix. The first one is transpose of matrix. Consider this matrix. A is equal to 2, 3, 5, 6, 8, and 10. We use a symbol A dash to represent transpose. Therefore, A transpose is equal to 2, 6, 3, 8, 5, 10. Can you say what kind of operation we did here? We interchanged the rows to the columns. So the rows becomes columns here. So A transpose is actually reversing the rows to the columns. If the elements of two matrices are same, then we say that they are equal matrix. For example, A is equal to 3, 5, 8, 6. This is one matrix and B equal to 3, 5, 8, 6. So these are exactly equal. Equal number of rows, equal number of columns, and the elements are also same. That means elements are in the same order. Only this kind of matrix are called equal matrix. Consider these matrix. A is equal to 3, 1, 6, 5, and B is equal to 3, 6, 5, 1. You can see that the elements are same but not in the same order. So these two matrices cannot be considered as an equal matrix. So what are the rules to be considered for calling two matrices are equal? One, both matrices have the same order, that is same number of rows and columns. That is the first rule. Now the second rule, the corresponding elements of both the matrix are equal. Now let us consider some other operations of a matrix. The first one is addition of a matrix. Consider these two matrices. A is equal to 2, 5, 6, 7, and B is equal to 1, 3, 4, 8. Find out A plus B. It's equal to add first element of the first row with the first element of the second matrix, that is 2 plus 1. Now the second element in the first row of a matrix A with the second element of the first row of a matrix B, that is 5 plus 3. Similarly, we can add the first element of the second row, that is 6, plus first element of the second row of matrix B, that is 4. 7, that is the second element in the second row of matrix A, added with the second element in the second row of matrix B. It's equal to 3, 8, 10, 15. This is the way to add two matrices. Now the second operation is subtraction of matrix. The same rule and method is used for the subtraction of matrix as is used for the addition of matrix. Consider the following example. A is equal to 5, 3, 4, 6. And B is equal to 1, 8, 9, 2. To subtract these two matrices, that is finding A minus B, subtract each element in the first matrix with the corresponding element in the matrix B. That is first element in the first row, 5, subtracted first element of the first row of matrix B, that is 5 minus 1. Similarly, 8 subtracted from 3, that is 3 minus 8. 4 minus 9, 6 minus 2. This way, the corresponding elements in each matrix are subtracted here. It's equal to 4 minus 5, here also minus 5, 4. From the above operations, we can see that in addition or subtraction of matrices, the order of the resulting matrix is the same as the order of matrix added or subtracted. So here we subtracted a 2 by 2 matrix and the result is also a 2 by 2 matrix. In the operation of addition, also we found that the same rule is kept.